Hi everyone. Today's class we are going to discuss about the basics of engineering subject in which we are going to discuss about the communication system. Let me move towards this slide. So the topics we are going to discuss in today's class is communication system block diagram, modulation, what is modulations, how it is happening, then different types of communication systems. These are the things we are going to discuss in today's class. First we will see about the block diagram of communication system. Communication is the transformation of an information. How we are going to transform the information from one person to the another person. Okay. So if a person is in a room, then we can able to easily communicate. But if we want to communicate to a person which he is very far away, then we need to have some type of arrangements. For example, you can able to see in the screen there is an information source is there and destination is there. So there is a large gap between the information source and the destination. So how I can go able to transmit my information to the destination place? For that, I need to have some media to which I can able to transmit from the source to the destination. That media is commonly called as a channel. So if I want to transmit my information source to the destination, I need to have some channel. That channel will be normally called as an air, optical fiber cables, copper wires. These are the channels which I can able to transmit my information from the source to the destination. Okay, so you can able to see in the screen. So information source, transmitter through a channel. What we have discussed, that is, this channel may be an air or an optical fiber cable or a copper wire cable. Okay, then you will have a receiver, then receiver will be given to the destinations. So when we are using the channel, there is a chance of adding the noise. So noise is the unwanted signals which will be joining with our own source. Okay, so normally we should reduce the noise source. Okay, so this is the basic block diagram of a communication system. So next we will move towards the modulation. Okay, so we told that we have an information system. That information should be traveled to a very long distance, but the information will be a low frequency signal. Okay, normally you can able to see in the screen, it will be about 20 hertz to 20 kilohertz. So this normal message signal cannot be transmitted over a long distance. Okay, so if I want to transmit this normal message signal to a large distance, I need to have some carrier signal which should be carried. Okay, so you can able to see the carrier signal. The carrier signal will be carrying this message signal for a long distance. Okay, that terminology is known as a modulation. So modulation is nothing but superimposing the message signal over the high frequency carrier signal. Why we are going for modulation? What is the need for the modulation? Okay, so if you are not having the modulation, the antenna dimension will be greater. Okay, so this antenna dimension is directly proportional to the wavelength, quarter of the wavelength. Okay, so if the for example, if you are taking 5 kilohertz, then the antenna size will be 15,000 meter. So you cannot able to imagine to install a 15,000 meter length antenna. So if I want to reduce the antenna dimension, then I want to reduce the then I want to modulate this signal. Okay, that's the main reason we are going for modulation. Then second one is interference. So already we have discussed that we are sending the information in a common channel. Okay, so there is a chance of missing with another stations. Okay, so different peoples will send the audio signals in a same channel, then there is a chance of mixing with the in a common channel. Okay, which will cause an interference. So how can I reduce this interference? Okay, by using the carrier wave. So I can use a high frequency carrier wave for a different stations. Okay, for example, if you take an FM radio, 98.3 FM, 93.66 FM, Like that we can have a different frequency stations. Okay, so by using modulation I can able to reduce the frequency. Then ease of radiation. Ease of radiation means I can able to easily design the system because I'm using a high frequency carrier wave. Because of that high frequency carrier wave, I can able to easily design the system. Then adjustment of bandwidth. Okay, so when I'm doing the modulation, I have the flexibility to do the adjustment in the bandwidth. What is the plus point if you see means while adjusting the bandwidth I can able to reduce the signal noise ratio. That is the main thing. I can able to improve the signal noise ratio. Okay, then the last one is effective utilization of the electromagnetic spectrum by using the modulations. So these are the things I can able to achieve when I'm doing the modulations. Type of modulations. So there are different types of modulations. Here particularly we are going to discuss about the analog modulations. The analog modulation is classified into amplitude modulation, frequency modulation, phase modulations. Okay, so this modulations is happening based upon the uh, modulated signal. Okay, so you can able to see here the modulated wave. Okay, this modulated wave. Based upon this modulated wave, we are going to change. Okay, for amplitude modulation, we are going to vary the amplitude. Okay, so in this diagram, in the figure C, you can able to see the amplitude is varying corresponding with the respect to the modulating wave. This amplitude is varying. Okay, what is frequency modulation? Frequency modulation in figure E, we can able to see the frequency is changing based upon the modulating wave. Okay, so for positive of cycle, you can able to see its frequency, and the negative of cycle, you can able to see the frequency change. If I'm changing the frequency, keeping the amplitude as constant, you can able to see in the figure E, the amplitude is constant, only the frequency is varying. Okay. Then the last one is phase modulation. You can able to see the phase modulations in the figure D. Okay, here the phase will be varying. Okay, keeping the amplitude constant, the phase will be varying. You can able to watch the figure D and E more or less same. So this frequency modulation and phase modulation will be coming under the category of angle modulation. Okay. So these are the various types of modulations. So when I'm doing the modulation and I'm transmitting over a single channel, I want to do some modulation techniques. Okay, so normally we will using the pulse modulation techniques for transmitting the signals in a channel. Okay. You can able to see the various pulse modulation techniques. The first one is pulse amplitude modulation. This pulse amplitude modulation will be, the pulse will be varying based upon the modulating wave. So you can able to see the amplitude is high during positive off cycle, and during negative off cycle the amplitude will be very less. This is called pulse amplitude modulation. The next type of modulation is the pulse width modulation. Here the width of the pulse will be varying. Okay, so the width will be varying according to the modulating wave. The last one is pulse position modulation. Pulse position modulation means the width of the pulse will be same. Okay, you can able to see the diagram. All the width of the pulse will be same, but the position will be varying based upon the modulating wave. So these are the techniques we are using to transmit the signal over the channel. Okay, for efficiently transmitting the signal. Okay. So this is how we are communicating and we are transmitting the signal over a long distance. Okay. So when we are transmitting over a long distance, we need to have some arrangements. Okay. So you can able to see the image. Okay. There's a two image. Okay. If you can able to remember, you can just type your correct answers in the comment box. Okay. So there is a two figure one and figure two. So this image is corresponding to the communication. That means first we have discussed what is communication, how it is we are going to transmit the information. Okay, by using modulation techniques. Okay, so when we are going to transmit, we should have some medium. Okay, we have already told the channel. Okay, so here there is a copper channel. Okay, so we are using copper wire as a channel to transmitting over a long distance. This is the um, basic method. By using the copper wire we are transmitting. Okay, so the figure 1 is the twisted pair cable. Okay, you can able to see the twisted pair cable which is used for transmitting the information and for data transmission. For everything they are used this copper shield, twisted copper shield. In figure 2 it is a coaxial cable, similar to that, where you can able to see in the cable TV connections. Okay, so there is an interference will be reducing. Okay, I can able to see the center conductor, where the center copper conductor where it is carry the information. Okay, so the both the figures will be using for transform the communications to an longer distance. What is the disadvantages in this system means the bandwidth will be very less. Okay, the signal distortion will be happening. Okay, interferences will be there. Okay, so that is the main disadvantages in this type of communications. Okay, then how we are overcoming this type of things. Okay, we are moving to different types of communication systems. Okay, the different type of communication systems, mainly we will discuss about the optical fiber communication, then satellite communications, then mobile communications. Okay, optical fiber communication mainly overcome the disadvantages of the copper wire communication. What we have seen in the figure. Okay, so when you are using copper wire figure, the bandwidth will be less. Okay, for that reason, we are going shifting towards the optical cable. Okay, when we are using optical cable, you can able to see the bandwidth will be low, wider bandwidth, transmission loss will be less, interference will be less, small size, reliability, low cost. Okay, so now today's the communication is happening over the optical fiber cables. Okay, so the major application of optical fibers they will be using in land, industrial electronics, telecommunication systems, etc. Okay. So optical fiber, as the name itself indicates, optical. Optical means light. Okay, we are going to transmit the information using the light pulse. Okay, so I can able to see here there is a core cladding. Okay, so this core will be carrying the light pulses. Okay, covered by the cladding. Okay, so how this light will be traveled in this core means by using the technique called total internal reflection. Okay, so we will see how what is total internal reflection. So before going to see the total internal reflection, this is the optical fiber cable. So here you can able to see the word letter N1, N2. Okay, so N1 represent the refractive index of the core. Okay, then N2 represent the refractive index of the cladding. Okay, so why this refractive index changing means based upon the material we are using. Normally for core we will be using the pure glass. Okay, so the refractive index will be N1. For cladding we will be using the doped glass, so the refractive index will be N2. Normally N1 will be greater than the N2. Okay, so when the light is incident in the medium, okay, always it will be refracted. Okay, so you can able to see here the light is incident in the medium, then it is get refracted. Okay, but based upon the angle incident, there may be something changes may be happen. Okay, you can see in this slide, when the light is incident at the angle greater than the critical angle. Okay, then instead of refracting, the light is reflected. Okay, so this type of reflection is happening, this known as an total internal reflection. Okay, so in optical fiber we are using this total internal reflection. So this optical fiber cable is classified into two types: step index fiber, graded index fiber, based upon the refractive index. Okay, so here the refractive index will be N1 will be greater than the N2, but in a graded index fiber, uh, the grade refractive index will be from the center, it will be reducing. Now we will see how the optical fiber communication is happening. Okay, so already we have seen the block diagram, information source and destination. How we are going to connect this? By using the optical fiber cable. Okay, so we know that it is an optical fiber, so our information should be converted into an optical. So first our information should be transferred into an electrical form, then it should be converted into an optical form. Okay, so optical means I need to have an optical source. Normally we will be using the LED, okay, light emitting diode, as an optical source. Okay, uh, then we need to transmit through the optical fiber cable. Then at the destination we need to have some uh, a receiver. So here we'll be using the photodiodes. So you can able to see the block diagram. So from the information, it will convert into an electrical transmit. Then it will be transferred into an optical source using LEDs. Then it will be transferring to the cable. At the end, there is an optical detector. Normally, photodiode will be using. Then it will convert into electrical receives electrical signal. Then it will reach the destination. So this is the optical fiber communications. Next, we will discuss about the satellite communications. Satellite communications, you can able to see it will be mainly used for longer communications. Okay, so from there is an earth station 1 from which the signal is transmitted to the satellite, then it is received at the some part of the point earth station 2. Okay, so normally the satellite communication will be using a will be used for various purposes. For example, if you are using GPS, okay, in any um, circumstances, we can use it for meteorological purposes, weather conditions, for everything we can be using this satellite information. So we will discuss about how this communication is happening. Okay, so how we are placing the satellite? Okay, so based upon the orbital patterns we are placing the satellite. Okay, so it is classified based upon the height, low altitude satellite, medium altitude and high altitude based upon the kilometers. Okay, so if it is 150 to 500 kilometers in height, it will be in the low altitude. If it is 9,500 to 19,000 kilometer, it is medium. If it is 35,786 kilometers, it is a high altitude. Where the satellite is placed. Not only we'll be placing the satellite, how the satellite is revolving. Based upon also the orbital pattern is based upon that also we are classifying the satellite. Okay, so if the satellite is placed in the equator, okay, equatorial orbit. Okay, if the satellite is placed in the polar orbit, that means it is revolving around the over the north and south pole. Then it is called a polar orbit. So if you are placing the satellite in any other places other than polar orbit, it is called as an inclined orbit. Okay. So normally we will be placing the satellite based upon the altitude and based upon the orbit. Okay. So next we will be seeing about how this satellite communication is happening. Okay. So there is a three-part in this satellite communication, as we have seen this diagram. Okay. So there is an earth station from which we are going to transmit the information to the satellite. Then there is the processing, the data will be happening. From this, it is again resend the data to the receiver in the earth station. So first we will see the block diagram of earth station transmitter. Okay. So we will have a signal. That signal is normally we will have a voice, video message or anything. Then we need to process this information. It will be encrypted. Okay. Then will be modulated. Okay. Modulated by using the here they are mentioning PSK, phase shift. Okay, by using the phase shift modulation or quadrature amplitude modulation, we are modulating the signal. Okay, and it is given to the up converter. Okay, so when you are giving the up converter, the signal will be in the intermediate frequency range. Okay, but we are going to use the satellite. For satellite, we are using the radio frequency. So we need to convert the intermediate frequency into radio frequency. Okay, so that is happening in this up converter. Okay, after we are converting to the radio frequency, we are giving to the HP. HP is a high power amplifier. Okay. Normally, high power amplifier will be klystron and traveling wave tube amplifier will be used. Okay. So in between this, there is a filter will be there, band pass filter. BPF means band pass filter. So in satellite, what is happening? So we are receiving the signal from the Earth. Okay, from Earth station we are receiving the signal. So there is a low noise amplifier is there. Okay, the signal will be very weak because it is traveling over a long distance and then it reaches the satellite. So we need to amplify this. Okay, for that we are using this low noise amplifier. Normally we'll be using the tunnel diode amplifier or parametric amplifier for amplifying the signals. Okay, then we amplified, when we amplified, then it is given to the high power amplifier, then it is again giving to the earth station. Okay, then we are going to discuss about how what is happening in the earth station. Okay, so from satellite we are receiving the signal, we are again the signal will be weak, so we need to amplify the signal by using low noise amplifier. Then we need to demodulate. So the radio frequency should be converted into IF, intermediate frequency. Okay. So first in transmitter we see the up converter. Here we are seeing the down converter. In down converter, what is happening means this radio frequency is converted into intermediate frequency. Okay. Then it is demodulated. Okay. So in transmitter you are seeing the modulation. In a receiver you are seeing the demodulation. So this is the thing, how the information is transmitted from Earth to satellite, then to the receiver. So this FDM, this is the frequency division multiplexing, time division multiplexing. Okay. So for example, communication satellite, I can see Intelsat. Okay. So international satellite are used for telecommunication. There is 119 members countries is there. In India, there is an INSAT satellite is there, mainly for communication for an Indian regions. This is an example. So if you see the advantages of satellite, okay, so it will be used for telecommunications, meteorologicals, global positioning systems. Uh, for that purpose, we will be using this. Okay. So if you see what is the disadvantages means time lapse will be there. Okay. So delay will be there because we are transmitting over a longer distance from the earth to the satellite, then we are getting. So there is a time delay will be there. So if there is any malfunctionings, it is difficult to correct. Okay. Then initial cost is high. That is the main disadvantages. Next, we will discuss about the mobile communications. Mobile communications mainly between the individual, okay, for communication and for exchanging the data. Okay. So the key factors in the mobile communications is wireless network will be using for testing the message, for voice communications, for location-based services, mobile application devices. For that, this mobile communication will be uses. Okay. So up to this, we will complete it. So all the data is taken from this reference books. Okay, thank you.